Okay, today we're going to talk about our last topic in our foldable, and our foldable is on Unit 14, Effects on Functions, and today we're going to talk about inverse functions. So it'll be a little bit different than what we've done with the last three tabs. The other three tabs, we've moved around graphs, we've changed them. Today we're still changing the graph, but it will look quite a bit different than the original one, and we'll talk about why when we do the problems. Before we talk about inverse functions, and you'll write these notes in your foldable, let's talk about what a function is in general. An equation is considered to be a function of the graph if the equation passes what's called the vertical line test. What that means is if you can draw a line straight up and down, a vertical line, and you hit more than one point, then it is not a function. Okay, the original equation is not a function. So if you look up here, I have two examples. So I'll use my blue pen up here. If I can draw a line straight up and down, like that, and I hit more than one point, then it's not a function. Notice how right here, I only hit one point. So this would be considered a function. Okay, that's still a function. On the second one, if I draw a vertical line straight up and down, like that, notice how you hit more than one point. I actually hit 2 points on that green graph. So therefore it is not a function. Okay, that's not a function. When we have two functions that are actually considered inverses of each other, what that means is you can take both functions and reflect them across the line y equals x, which I wrote there. So I'm going to graph the line y equals x. That has a y-intercept of 0, and it has a slope of 1, so you would go up 1 over 1, up 1 over 1, okay, up 1 over 1, and so on. Okay, so the line y equals x, okay, would look like that. And if two things are functions, we should be able to graph them, and it's going to be a reflection over that line, and I'll explain what reflection means. So let's go ahead and look at this graph right here, the f of x graph. I'm going to go ahead and graph that in red. So that has a y-intercept of -4, which is right here, and my slope right here is 2. So I'm going to go up 1, 2, and over 1, up 1, 2, and over 1, and so on. So let's put that right here. Okay, so that graph will look something like that. Okay, let's look at the other one, which I will do in blue. So g of x equals 1/2 x plus 2. So I'm going to put a dot on my y-intercept, which is 2, and I'm going to go up 1 over 2. So up 1 over 2, okay, up 1 over 2, or I could go down 1 to the left 2, like that. Okay, and I'm going to go ahead and draw that one. Okay, so there's the two graphs. What it means to be a reflection, it means if I put a spatula, okay, if I took a spatula and I put it underneath this red one, and I flipped it over the green line, I would get the blue one back. So it's like flipping a pancake. So again, if I took something and I put it underneath this red line and I flipped it over the green line, the blue line is what you would get back. That's what they mean by reflection. Okay, so let's go ahead and look. We just talked about if a line is reflected over the line, y equals x, okay, then you get the inverse. So what that means is you can switch your x and y value around. So I wrote up here, two functions that are inverses. You can take the domain and you can take the range and you can actually interchange the values. You can switch them around. So I wrote a few examples up here. So let's go ahead and look. So what that means is if 2, -3 is in f of x, then it's asking what coordinate is in the inverse. Well, I simply can switch the two coordinates around. Okay, so my new x value becomes my other y value, and my y value becomes our x. Okay, so let's look at the second one. Same thing. If 5, 2 is in g of x, then it's saying what coordinate's in the inverse. Okay, well, that means that 2, 5 should be in the inverse. Okay, I can switch them around or interchange them. And this last one, if f of 2 equals 5, then f inverse of 5 should equal 2. Again, that's the same thing as what I wrote above. You can switch the x and y coordinates. Okay, for a set of coordinates then, we just talked about how you can switch them to have an x and y coordinate. You can switch them to get the inverse coordinates. For a set of coordinates to have an inverse and be considered a function, each element of the domain is assigned exactly one element of the range. So that means each x value has exactly one y value that goes with it. So in this problem, I wrote down a set of red coordinates and a set of blue coordinates, and we're going to find their domain, range, and tell whether it's a function. Okay, so let's go ahead and look. I'm now writing green. So the domain, remember, is the x coordinates. So in this red one here, My x-coordinates are 2, -3, and 4. So that would be considered your domain. Your y-coordinates would be considered your range. So if you look up here, the range, the y-coordinates are 5, 7, and -2. And we want to know if this is a function. Well, if you look up here, each x-coordinate, there's only the x-coordinate written one time, so each one is actually assigned to exactly one y-coordinate. So this one would be considered a function. Let's go and look at our blue. Okay, our domain for our blue ones, we have -2, 5, and -2. So -2 and 5 are your only x-coordinates. Your range are your y-coordinates. So I have 3, 6, and 8. And so it wants to know if this is a function. Notice here how -2 shows up twice. That means -2 was assigned to a y value of 3 and a y value of 8. Since it was assigned to 2 y-coordinates, then this would not be considered a function because one x cannot go with 2 different y's. Okay, that's what it means to be a function. Okay, so let's what's in the last part of our foldable then by talking about how we actually find an inverse. So I wrote 4 steps up here. Okay, and it's actually really 2 steps. Okay, it's not as hard as it sounds. So step 1 is rewrite f of x as y. Step 2, switch x and y. Step 3, resolve for y. And step 4, rewrite y as f inverse of x. So again, step 1 is pretty easy, so I'm going to put a little 1 here. So it says go ahead and take f of x and rewrite it as y. Okay, so all I did was replace y with f of x. Step 2. Okay, so go ahead and take x and y and switch them. Okay, so that's pretty easy. Step 3. This is really the main step. Say go ahead and resolve for y. So I want to solve for y. And that means I want to get y by itself. So to do that, let me give myself a little bit of room here. Okay, so to do that, we're going to add 8 to both sides first. So on this side, you have x plus 8 equals 5y. And now I want to get rid of that 5. Since I'm multiplying, I'll simply divide everything by 5. Okay? Okay, that's what I get when I resolve for y. Okay, your last step, that answer that you got is actually the inverse. So it says x plus 8 over 5 is your inverse. So I'm going to just rewrite y as f inverse of x. Okay, so that's how you would find your inverse. Okay, you can write it like that. One thing to understand is another way of writing it if you want. Let me just write it over here so you can see it. That 5 goes under the x and the 8. So I could really rewrite it like this if I want. Okay, it doesn't matter. I leave it like a fraction bar. But the only reason I write it that way is because based on this, you should recognize this is an equation of a line, which means your domain is all reals. Okay, and your range is also all reals. So if they ask that question, your domain is all reals and your range is all reals because your inverse was another line. Right, for our last problem, let's go ahead and find the inverse. I'll show you one other example. Okay, we don't need to find the domain and range, but remember, domain just means the x values that show up in the graph, and the range are the y values. Okay, so here's my function. Don't worry about this part. This is just making sure it has an inverse, so you don't have to do anything with that. So remember, step 1 in finding the inverse is go ahead and replace f of x with y. Okay, so I did that. Step 2 then is to switch x and y. Okay, so where there is an x, put a y, and where there is a y, put an x. Step 3 is to solve for y, to get y by itself. So again, this is the one that takes a little bit of work. So I need to move the 4 over to the other side. So I have x plus 4 equals y squared. And then to get rid of that squared, remember you would take the square root of both sides. So the square root of x plus 4 should equal y. Okay, so that function is your inverse. So remember step 4, you go ahead and put that there and you replace y with saying it's the inverse. Okay, and that would be your final answer to show what the inverse is.